All right, in this video we're going to do this AP Calculus free response problem that gives information about the first and second derivatives and asks you to analyze a bunch of things about the original function. Okay, so g is defined for all positive values of x, with g of 1 is 2, so they're giving you an initial condition. And then they're giving you an equation for the first derivative and equation for the second derivative. All right, part A. Find all values of x between 0.12 and 1 where the graph has a horizontal tangent line. Okay, well, we know that if the tangent line is horizontal, that means the slope is 0, or g prime is 0. So I'm going to go into my calculator. Okay, so I'm going to put the first derivative equation into y1. Let's set that up right here. So y1 is going to be the first derivative. So I have first, I'm going to make sure I'm in radians, which I am. And in y1, I'm going to type the sine of x plus 1 over x, okay? And I want to know when this equation equals 0, or in other words, when this equation crosses the x-axis. And so I'm going to set my window up. I'll go from 0 to 1.5. 0 to 1.5. And then I just need to see the x-axis. I just need to see where y is 0. So I'm going to set my y window to go from -1 to 1. All right, and I'm going to press graph. Oh, wow, there's a lot. So this is probably why they started at 0.12, so I don't have to give a lot of answers. So now I'm going to change my window to 0.12. Okay, so you can see that my first one is right there and my second one is right there. Okay, so this, I'm going to calculate the zeros. Second, calculate number 2, 0. And left bound, right bound, I'm going to call my left bound 0.12. And then my right bound, I'm going to guess, if this is 1, I'm going to guess 0.2 will be good enough. Okay. If it doesn't wind up on that point, I'll have to just change my limits, but there I get 1. Okay, so I get that x is 0.1634, and then now I'm going to find the second one. Second, calculate number 2, 0, and I'm going to say between 0.2 and, well, I can go all the way out to 1 now. I can see there's only 1 left. Oh, no sign change. Let's try this again. Second, calculate 0 between 0.25. There we go. And 1. Why is it doing that? Well, that's annoying. Maybe I'll use the arrow keys. Okay. That's very peculiar. Anyways, I've got a second one. X equals 0.3594. And, yeah, those are my 2 answers. Great. Okay. So, part B. On what subintervals is the graph concave down? Okay, so let's think about when is that going on. G is concave down when the second derivative is negative. Okay, so I could, let's see, I'm going to use the second derivative equation. I could do this two different ways. Because if the second derivative is negative, I could also say that means when the first derivative is decreasing. It might be good to check both of those, because that will tell me when that I'm correct if I get the same answer, but I'm going to start with the second derivative. So I'm going to type the second derivative equation into my calculator. So 1 minus 1 divided by x squared times the cosine of x plus 1 over x. Okay, now I don't want the first. I'm going to turn the first derivative equation off, and I do that by just going over there, putting my cursor over the equal sign, and pressing enter. So now only the second derivative equation is highlighted. I'm just double checking that I've typed everything in correctly, which it looks like I have. And now I'm going to graph the second derivative from 0.12 to 1. And I'm probably going to need to change, yeah, okay. So let's see, let's change my window so I can actually see what's going on here. Second, calculate, or no, I'm sorry, window. Let's go from maybe -5 to 5 and see if that works. Nope, I need a little more, maybe -10 to 10. -10 to 10. Okay, so it looks like the graph is negative for all the values of x before this one. So, oh, no, wait, what did I set my window up? 0.12. Oh, it looks like there are two intersections. I'm going to change my window again. Let's see. Yeah, the graph comes down and then goes back up. Wow, how far down does it go? Really far down. Let's go to -50. There we go. Okay, so now you can see the graph comes down and then goes back up. So from here to here, the graph of the second derivative is negative, so I need to find that point and that point. So I'm going to calculate the 0, and I'm going to start at 0.12. And I'll go to, I don't know, 0.25. Oh, that's going to be too big. I'm going to have to switch that. Let's see, it's giving me the second one. So I'll write that down. 2, 2, 2, 7, 3, 4. And now I want that one. Second, calculate 0 from 0.12, which is the left side of my window, and let's just go 0.16. I don't know, is that going to be, there we go, you see the arrow right there. And I'm getting, so the two values that I just found are where the second derivative equals 0. And so G prime, double prime is negative between those two values. So I'm going to say from 0.1295 to 0.2227. Okay. All right, part C. Hold on one second. There we go. Okay, great. All right, part C. Write an equation for the line tangent to the graph at x is 0.3. Okay, so we are going to need a couple of things here. I've got my first derivative and my second derivative typed into y1 and y2. Okay, first I'm going to need a point. To write the equation for the tangent line, I need a point and a slope. So I need g of 0.3. I have a starting value. In the beginning of the problem, they gave us that g of 1 is 2. So g of 1, and I want to move backwards from 1 to 0.3. So I need to subtract the integral from 0.3 to 1 of g prime. And so I'm subtracting the change that happened from 0.3 to 1. G prime is the change in g, to figure out what is the value of g of 0.3. So that's going to be 2 minus the integral from 0.3 to 1 of g prime of x dx. And let's remember that in my calculator, I have typed g prime into the y1 equation, so I can use the vars menu. So I'm going to do math 9, the integral of vars y1 from 0.3 to 1, and that is 0.45399. And I want 2 minus that value. So I have g of 0.3 is 2 minus 0.453, and I get 1.546, I think that says 54600. Okay. So now that's my point. Okay, so that's the ordered pair that I'm going to use. Again, my point is 0.3, 1.5460. And now I need a slope. So that's going to be g prime of 0.3. And I'll just store that in case I need it again. I'm going to write here what I stored it as. That is stored as A in my calculator. Okay, so g prime of 0.3 is just g prime is y1 of 0.3, and I get negative 0.4722. Okay, negative 0.4722. All right, I am ready to write the equation of my line. Y minus 1.5460 is slope negative 0.4722 times x minus 0.3. Okay. All right, last part. Does the line tangent to the graph lie above or below the curve for g is 0.3 to 1 and y? Okay, so if you recall, if you can visualize how a tangent line looks along a curve, if a curve is concave down, then your tangent line always lies above the curve. Anywhere along a concave down graph, the tangent line lies above the curve. However, if you have a graph that's concave up or convex, then your tangent line is going to lie below the curve. So in order to answer this question, I need to know, is the second derivative positive or negative in this interval? And we actually already looked at this graph, but let's go back to the graph. So again, I have the second derivative here in the y2 equation, and we looked at the graph. This was from 0.12 to 1 from when we were doing part B. And we found that this point right here, this 0 right here was at 0.22. So if I just move my cursor, oops, let's get the cursor on the curve. You can see if I move my cursor along the curve, that's 0.22 is about where the 0 is. So right there, x is 0.23. For all of this part of the graph, you can see the y values down here, is above the x-axis, or the second derivative is positive for all of these values. Okay, you can see the second derivative is approaching 0, and I think when x is 1, we actually get 0. There we go. So, but for this interval, the second derivative is positive. Again, we don't need to go into this much detail, but kind of summarizing what we saw from part B, starting at 0.12 and going to 1, we had that 0.1295 was a 0, and 0.2227 was a 0, and 1 was a 0, and then according to our graph, the second derivative is positive in this interval, negative in this interval, and positive in this interval. So, hence, from 0.3 to 1, the second derivative is positive. So, G is concave up on the interval 0.3 to 1. Therefore, the tangent line lies below the graph. If you were to use the tangent line to approximate a value of the function in this interval, this would be an underestimate because the tangent line is below the curve. All right, that's it.